Well, we're just setting a stall up for making up the lead screw, having a degree of success with the trial piece. There's a couple of dimensions I've got to confirm. That's a 3/8 fine width with fine thread. There's a nut to hold the handle on, so that's long, a bit further down the line from where I am. So the lathe's just getting it set up. This is the initial piece I've roughed out. I just want to bring the diameters down now to within a couple of thou and then get them all down to dimension. I'm going to turn the ACME thread and the 20 threads per inch section here, then flip the lot round, because that lot will then stuff up the spindle, and I can just then turn from the collar, which locates the graduated disc, or setting disc. I can locate that and then turn the rest of it on a shorter stub. That's the plan. I'll bring you back when I've got it roughed down. Well, I've roughed it out, so that's finished dim, that's finished dimension bar. Got to set the thickness from the other side. That's the run out for the thread, starting bit for the thread, which will later get turned away. And I've done half a dozen scratch passes just to make sure everything's set up right, and it seems to be. I've re-honed the high-speed steel bit, and from what I'm running at, when I'm threading, I'm somewhere between 70 and 100 RPM. The depth of cut I'm taking on each pass is put on by the cross slide, not the compound. I've set the compound at the right angle, but decided I'm going to cut it in square. And initial cuts are going in at 0.1 mil until I get to 5. So I've got another couple of passes, and then once I'm at half a mil depth, I then have to go in at half that until I'm at 1 mil, and then the last, I think it's 0.6 mil of infeed is taken at basically a thou a time, and it's a bit nerve-wracking because it goes bing ding bing, and you could, well, yes, when I did the sample piece, I was watching the tool dip away like this. So yeah, we'll take it easy. I'll set you up in the overhead holder, and well, maybe you'll be able to see what I'm doing. Best set it forwards. Right, so we move back to the to the infeed section, stop it, set the direction, put the feed on, and then press go. And then once we feed in, we can wind the speed up a bit. That's at 90 RPM. And what I found is, obviously, the faster it's running, the longer it takes, more revs it takes to stop. So I have to get towards the last 3 or 4 revs from the end and drop the speed right down before I hit the stop. So I hit the empty space. Then we reverse direction, 1 full rev out on the cross slide. The reason for doing 1 full rev is it takes up any backlash, and it also means I can take it back to the position, accelerate it back to the start. Stop it, back to going forwards, or change the direction, put the feed on back to a 1 full rev, and because I've done 1 full rev back, I know where I left the feed, so I put the feed on and then press go again. And dribble on some oil. It's a bit tedious, but at least it's doing it. You have to wind the tool out, or I have to wind the tool out before a reverse direction, because there's enough backlash in my feed nuts to wreck the thread. Wind it out of rev. Change direction, take it back to start. Reverse the direction, 1 full rev of in feed to back where we were, put the feed on, go. Now as the depth increases, we're cutting on both sides of the tool and the bottom at the same time, so there's 3 cutting faces. So the feed in feed is reduced right down, but I've also found every other pass I do a spring pass. Makes for a neater cut, but it also takes some of the gritting of the teeth bit away. The way it was pinging yesterday as I was trying to work out what feeds to use, it was a bit scary. I just figured the end of the tool would get broken off. Reverse direction, 1 full rev out, back to the start. Change the direction, 1 full wind in, put the feed on. So I'm feeding 0.05 of a mil per pass. And about half a pint of fluid per cycle. So we're cutting 10 threads per inch, ACME thread on a 5/8 diameter, and it's all being done on the metric lathe without the compound change gears. Change the direction, 1 full wind out, back to the start. We've got a 20 tooth on the stud gear, which comes straight off the spindle, and then we've got a 46 tooth gear into the Norton gearbox, and then we're running with position D3 on the gearbox. This is a Boxford AUD Mark III, so it's a 5.5. It's 5.5 inch centre height. Change direction. Wind him. Go. I didn't put any feed on this, so this is literally just a spring pass. You can see it's removing material. If you don't do the spring passes, it builds and builds and builds and builds, and then you end up taking one cut and it either binds up, or you can hear that front of that blade go ping. I also found yesterday, as the thread depth got deeper, I was having to brush the swarf out with a brass brush. Not so much of a problem once I've worked out that I'll be better with a lighter feed rate. Sorry for the wobbly bit. So I'm not here to tell you how to cut threads. It's this is how I've worked out how to do it this end, using advice from the various online forums, and specifically the one for the Boxford lathe, which is the manufacturer of this lathe, an old English one. I'm no machinist, I'm no engineer. I'm making it up as I go along, and if you can gain some advantage by watching the videos, then that's brilliant. I've pretty much gained all my knowledge by watching videos on YouTube. Got to be a good thing. Bring you back when I've got a bit deeper. And we're getting down there now. I've lost count of how many passes. We're now at 1.4 mil of in feed, and we've got to go to 1.6. So we're taking out I think it's 1 thou per pass of depth, which obviously by the time you've gone around the tool is quite a bit of material. We've upped the speed a bit, we're now at 130 RPM. I think that's a confidence thing more than what works, but it's working for me. So I'll put you up in the overhead camera and then you can see how it's going. To use the inch facility to get it to its end stop. Probably using far too much oil, but I figure it's helping shift the swirl and it's giving me a cleaner cut. That's just a brass brush. And I'm sure some of you guys out there got faster reflexes than me and you'd be stopping it right on the spot. My reflexes are shot. Bit of oil. We actually did it on that one. So just I've got it down to depth, giving it 4 or 5 spring passes, and we just, I think that'll bed on all right. That. Getting a bit stiff towards the end, which is obviously when the misalignment of the pitch, which is a thou and an inch, I think it is, something like that. Probably come a little bit, take a little bit more off. Yeah, that's a little bit more off, I think. Although it's gone easy now, so it's probably just cut a little bit out of the brass. Looking at the discoloration of that. So I'm inclined to say I'm going to go over it with some fine emery, the top of the crests, and then I think we'll call that done. Hoorah! Probably took about the threading of it half an hour, but the key is definitely don't try and take too big a bite, because it's I mean, I guess on a bigger lathe you could do whatever you like, but it's not a particularly heavyweight lathe. It's a well-made lathe, but it's not heavyweight. Anyway, I'm happy with that. That's worthy of Stefan's scrap bin. So I just took the one last spring pass, and it's gone from being tight to being no discernible wobble. Nope. But you know, finger job. I couldn't see anything coming off, but you can, if I don't get seasick on me, on the tooltip, that's all it's took off. I very nearly ran into the end here. Anyway, we've done that now, so I need to bugger about with the gear changes and get ready for me. It's a 20 threads per inch, and I've got to assume the width with, because everything else has been width with. Righto. Well, I've cut the thread, which is 20 threads per inch, and I've used the existing nut, and it has been an absolute pain in the arse. And it turns out, when I've looked closely, that's obviously the one that's been raunched up to lock that. It's had a bit of abuse, but I think it's stretched the threads inside there. So the first nut went on no problem, and it's took me best part of 45 minutes messing about getting the second nut on. The thing is, I've really got no means of cutting a 5/8 by 20 internal thread in anywhere near an efficient manner, so I was getting to stage thinking, oh crap, I'm going to have to make a new shaft and then make that section something like an M16. Anyway, so far it looks as if it might get away with it. So I've spun the shaft round, I've clocked it up on that dimension and that dimension. We'd already got centre hole in it, but I wanted it running as true as I could before I centred it. So this is the area we're taking off. That area, that section there, sits inside that collar. Now that collar's got 125 grad on it, which is no use for us because we're now on a 100 thou per rev, or 1/10 of an inch. So I've got to remachine the graduations, in which case by the time I've finished pissing about cleaning that up, I might as well make a new one. So I think that's what I'm going to do. I'm going to make it a little bit larger as well, so that the graduations are bit broader spaced. When it sits on top of the tool head, there's ample space for it to go. It could be another 5mm bigger, so centimetre bigger on diameter, which will make a huge difference when it comes to those graduation spacings. It's only a shape, you're not there to split thou. Yeah, I know. But by the time I've finished cleaning that up, make a mandrel so it fits on, so I can put it in the lathe and clean, you know, spin off, turn these off, turn that taper again to clean it all up, blend in the radiuses. I might as well just make a new one. So that's my plan. In which case, I'll leave that dimension where it is, but the one that it mates onto, I shall make a suitable dimension that it ain't got to piss around working with inches and whatnot. So there we go, that's where we're at. I'll bring you back when we've got it somewhat like. Well, that's all the turning done on the lead screw for the compound. I've left that a bit thicker. That's at 7/8. That's 1/2 inch, a nice snug fit on the handle, and I've put a 3/8 British Standard Whitworth fine on the end. So I've got to make a domed nut of some form to fit that. That'll hold the handle down, and then the handle's got a can you see that groove? That's like a pin's been made, a slot for a pin's been drilled in, so on the assembly I've got to put that on and drill that somehow, probably thread it as well. I've left it 1/4 of an inch long and dressed the thread start. Everything went well apart from that bloody thing. 20 threads per inch, and the nuts were just a pain in the arse. So what I should have done was not cocked it out and made new nuts and threaded them all at the same, but anyway, it's done. Don't think it'll take much adjusting of them to tear the threads out there. Anyway, in theory, once it's clamped up, it's only setting the end float on that, so there shouldn't be a great deal of problem anyway. Just cutting down a piece of shafting for the graduated dial. I'm making it, I need to cut it longer than I need so I can grip the thing in the jaws. Shafting's come from my favourite steel supplier. I'll show you the end of it. It's from scrapyard, but it's had a rolled key in it, and the keys looks to have been 1/2 inch or 3/4 of an inch. It's quite an impressive failure anyway. I had 6 different pieces. Most of them were hinge pins off things like excavators, but I took a file with me and the file was just skating across them, so I figured they were obviously surface hardened, something like induction hardened or similar, and I just don't fancy trying to work that sort of stuff, not on my small lathe. Whereas this one I could scratch it with a blade, so the saw's going through it alright, so it's not hard. Fit for purpose, not bad for £6. I'm always interested to see how stuff's failed. See the keyway, you can see how it's been rolled and it's virtually destroyed it. And then these wear patterns, and it's been walloped to get whatever it was off. The shaft itself was about 1 metre long, or the bit I've got, so I have no idea what it was off. Yeah, all good material for me. Anyway, I'll bring you back when we got the thing roughed out. We're making that basically. We're engraving or scratching in the dial for the tool head. So we've got a spin indexer clamped to the lathe bed. This allows me to do 1 degree and multiples of that increments. Obviously with 100 thou for 360 degrees I would need to be able to do fractional indexing. I can't. So I've got a line that goes between the two. Next one, that's 10 thou. That'll be 2.5. That's another 2.5. That's another 2.5. And there's your 10. So the dial shows 2.5 thou per increment, which is not great. I would have preferred 1, but I can't do it. And I haven't got anything with 100 divisions on. So you know, making that plate out with 100 holes would have been ideal, but I ain't got the time for it. But at 2.5 thou I could split that, and that'd be 1 1/4. Well, you know, I'm not bothered about the quarter, but I'll do that by eye on the machine. Or if I can get my head around how you set up a vernier, I might even put a little vernier scale on. So the next job is I've got to stick it up on the mill, machine a little pocket, drill a hole through, tap it, and that'll be the clamping position for clamping it onto the shaft, to the thumb screw if you like. Once that's done, I'll put it back into the lathe, spin it up, and just polish off the burrs, which are, come on, focus, there we go, they're not too bad. It's definitely better than the last time I tried to do this, where I was only doing pure degrees of rotation on that. Tedious. Yeah, I'm gonna have to try and get my head around how I could do hundreds on there, because it would be a handy feature. Anyway, enough of me babbling on. School run time.